All right, welcome back to Anatomy and Physiology here with Dr. Sean Clavel. And we're continuing talking about structural and functional classifications of joints. And in the previous sections, we talked specifically more about fibrous joints and cartilaginous joints. But today, specifically, we're going to talk about where'd that go? Today, we're going to talk specifically about the synovial joints here. And so I think we'll draw our attention a little bit more to this graph that we've been looking at because we can see here where synovial joints are a little bit different than that of those cartilaginous and fibrous joints. And uh, first, the binding material. We've already talked a little bit about how fibrous joints are held together by ligament or dense fibrous connective tissue. We've also talked about how cartilaginous joints are connected by cartilage, whether it's hyaline cartilage or fibrocartilage. And now, specifically, we're going to talk a little bit more about how the synovial joints might be a little bit different. And so the first is this concept of a cavity. You can see here that there's actually a space, and it's for the most part, it's what might be called a potential space, meaning that there could be room when our fingers when the joints swell. That's when we see that there's more space in between that. But for the most part, those bones are pretty close together, are close together, held together by ligaments and other structures. But there is space. There's potential space in between those joints. And the other concept here is that for the most part, these are our freely movable joints. So you can see here that all synarthroses, all synovial joints are diarthroses, meaning that they are freely movable, and these are the ones that are related to the joints of the limbs here. So, related to movement, perhaps, as we could say. So, the concept behind synovial joints is that there is a space between them. We don't see that present in either the fibrous or cartilaginous joints, where those bones are densely held together. There is actually free movement allowed in synovial joints. And again, as a result, these are the joints that are more related to the movement of our body, the joints of our limbs. So, as we've mentioned here, right, like synovial joints are characterized by the presence of a joint cavity. So there's a capsule that kind of holds it together here, and see if I can't uh, create a slide. There's a capsule that holds it together, and so there's cartilage on either ends of the bone and synovial fluid in between that space that provides a frictionless uh, area for movement to occur. Ligaments are on the outside, hold the bones together. There's actually ligaments on the inside as well. So let's look at the structures that are associated here with a synovial joint. And so first, as we've mentioned, the first thing that we'll see is that there's hyaline cartilage. Let's make that we'll start with our green color here. So there's hyaline cartilage, or what might be referred to as articular cartilage, and that lines the ends of the bones. That's what we're seeing here at the ends of the bones. So articular cartilage lines the ends of the bone. The other structure is that there's a cavity, a joint cavity or a space. And so that space we might just outline. Let's just maybe outline that in black because that is again, that is the you can see here, like this whole component here, this is the space that's created in between it, and it's really a potential space, right? The amount of space here is really minute, but the fact is that there is space here. It is filled with synovial fluid. It is called the joint cavity. There. We'll kind of say that we highlighted that in black. The capsule is, there's two parts to this capsule. So there's the outer fibrous part of the capsule where the ligaments actually attach to, and then there's the inner part of this capsule where, so we'll make it, let's make it like purple or pink or purple. Okay, so there's the outer part of the capsule, this is the inner part of the capsule. This is what secretes the synovial fluid. So you've got synovial fluid that comes out of this component here, and then there's the, we'll make this part pink because it's kind of a color consistent with that. This is the fibrous capsule. So then the ligaments, ultimately ligaments, can articulate into this component here. So again, there's the outside, there's the articular fibrous component, there's the inner synovial lining component right there. And so we've already talked a little bit about the ligaments and the fact that these ligaments are held together and they can bind into the articular capsule, right? So they can become part of the articular capsule, but they can also be inside of the joint itself. So I actually have a, let's go to this slide here. Excuse me. So what you'll also see is, again, so we're kind of right here, we're talking about these reinforcing ligaments. And so the reinforcing ligaments are going to be ones like your anterior cruciate ligament, your posterior cruciate ligament. And so these start from, again, the intercondylar eminence of the tibia. They go into the intercondylar fossa of the femur, and so these ligaments hold that those bones together. I mean, maybe if I did it like this, they hold those bones together like that. So there's one ligament there, there's another ligament there, and so they hold the bones from going too far forward or backwards. So you've got these supporting ligaments either in the joint themselves or blending into the capsule. That's what you can see here. They're blending into the capsule there. Bursa and tendon sheaths are structures that are associated with areas that we might see friction. So in the case of the knee, as you can see here, there's a prepatellar bursa. So there's a bursa in front of the kneecap. There's one in behind the, oh, that's the fat pad. The infrapatellar bursa, that's a structure that's associated with the patellar tendon. And so areas where bone, so you can see that there's some bone of the tibia and associated with the tendon of the patella. So areas where bone might meet tendon or ligament, you're going to find this bursa, or even like a fat pad that provides, and there it is, a fatty pad, provides some protection for that tendon, or and allows it to move, and again, in a more frictionless. So a bursa is even a synovial sac. That provides a frictionless movement across an otherwise harsher surface. There's the fatty pads as well, so they do the same, very similar structure here. If I'm going to erase everything, we can see that a fatty pad here, again, sits in the area where there might be some friction between either a tendon and the knee. So you can see right where the kneecap patella here starts to run into some of the areas of the femur and the tibia. There's a patellar fat pad. And then a, although common, usually somewhat unique structure. How should I say that? It's common. So there's fibrocartilaginous pads that we see, or discs that we see in many different joints, but they come in different shapes, might be the way to say it. So they come in different shapes as it relates to whatever joint that we're talking about. So in the knee specifically, these fibrocartilaginous pads are come in the form of the menisci. So you can see I'm kind of drawing the menisci. This is a mid-sagittal view of the knee. And so what we're seeing is that you've got these fibrocartilaginous pads of the menisci, but also you've got a fibrocartilaginous ring in your shoulder, which is referred to as the labrum. It actually deepens the socket just a little bit so that it holds the humerus in place. There's a labrum as well in the hip. Your TMJ, or your temporomandibular joint, has a articular disc as well that allows for a connection point as the jaw moves down and forward. And so, fibrocartilaginous discs or pads, articular discs, are not an uncommon feature in synovial joints, although in each joint, their shape or their structure might be a little bit different. And so, there goes our introduction into synovial joints, right? A space filled joint that has fluid in it. It's the type of joint that allows us to kind of get that pop, right? You get that pop your knuckles, or you can pop your uh, back even, so that we can identify those like synovial joints in the zygoapophyseal where your facets are, not in the bone disc bone connection, but down in the back where the superior articular process meets the inferior articular process. That's the synovial joint related to movement. And so we'll talk a little bit more about the different types of joints in the next section.